This is going to be a quick crash course on Python. Just going to go step by step through some of the concepts, some of the gotchas with Python compared to other languages. I'm going to be using Python 3.7. I'll show you a few things about the different versions. So I'm using Microsoft Visual Code. And what I've done is I have this thing set up to remotely connect to my Pi. So if you don't know how to do that, just go back to my previous video and I show you step by step how to install SSH and code and get them working together. So you can see right down here, it's now trying to set up my host, this Raspberry Pi.local, and I will enter my password to get in. So I'm going to have a look here at the variables and functions. So we're just going to start off with some very basic things. We're going to have a look at some comments, numbers, text. These are the types of objects, and we'll talk about that a bit later. But these are the types of things that you will find in Python and you'll be working with. Now that I'm logged in, I want to add a file. So right here in this folder view, I can click to hide or show. This is the documents folder on my Pi. And then there's a little plus. Gives me the ability to get a new file. Just going to call it test.py and enter. So what this does is creates a brand new fresh file for me to work on, and I can start typing. So in Python, if I want to have comments, I start with a hashtag, and I can type in any kind of comments to leave some breadcrumbs for myself or other programmers. The other thing that you need to understand is Python actually cleans up visually the code. A lot of times if you want to create a number, for example, you would see something like this typed in say a C language. But with Python, there's a philosophy that if it quacks like a duck and it walks like a duck, well, then it must be. And so I don't actually need to have that int put in the front of a number. Stands for integer, which is a whole number. And Visual Code actually gives me inspections. So it's telling me, okay, your interpreter is going to say that this is an int. So it knows this is a whole number. I'm also going to put together, these are called strings. And you can notice them because they are enclosed inside double quotes. And if I inspect this text variable, it says str. So that tells me behind the scenes, I'm actually looking at, this is of a type str. And that's another beautiful thing you can actually do is if you're not quite sure what you're looking at, you have these little tool tips that I can hover my mouse over top and it'll tell me, okay, what is a string object? It creates a new string object for the given object. And so you got all these different bits of information and tells you how to use that particular object. The same with the int. So we also have floating point numbers. And all I have to do is type in a decimal and I can start typing in, say, a 4.0. So I'm going to remove these types. I don't need to type those in. One of the other handy features is the collection of items. So I can actually have, this is called a tuple. And I just use a parenthesis. And I can actually create sequences of numbers, for example. I can also create a floating tuple. One of the conventions in Python is actually to use this underscore in between words. It's just their way of separating things out to make it a little more human readable. So if I have some floating point numbers, I can start putting in 4, 3.4, 5, and so on. I can also create a tuple of strings. So if I have a list of things that I want to keep track of, I can type those in as well. Now, if I hover over top here, I can see that this is indeed a tuple. And how do I know? It's because of these brackets. So I'll have the around brackets or the parentheses around. There's one more type I'd like to have a look at, and it's called a list. So I can create these list objects. Now I can start typing things in directly. I can put in some numbers, maybe some floating points, maybe some text. Is one way of doing this. I can put together another list. And what I'm going to do is actually make use of what I've typed already. So instead of having to type all this information all back out again, I'd really like to collect all of my variables here all in one place. So this is something that might be a little odd for some of us, being able to collect things. From a C background, we're used to having arrays, which only has one type. So if you have an integer array, it's all integers. You can't mix. Python has a little more flexibility in the fact that I can mix all kinds of types in here. I can put numbers, text. I can put a floating point in here. I can actually even put in another list. Really, I can put in whatever I want into this thing. So I'll save this, just check for errors. I want to run this program. What do I have to do? Well, in Visual Code, there is a terminal that I can go to. So up in your menu, there's terminal. And I can create a new terminal. Now, because I have this file open, just right-click anywhere on the file, and you can actually see I can run the Python file in terminal. And if everything's set up quite nicely, you can see it's done that here. I'll just move this over so you can see. You can see Python 3 has actually run my file here, test.py. Okay, we're going to move on to functions. So in order to create a function in Python, we're going to start with a def keyword, and that will define a function of some kind. I'm just going to create an add numbers function. And in there, I'm going to accept two variables. Now, something you need to know with Python is it is a tabbed language. So for example, in other languages, you'd have some sort of bracketing. This is actually kind of noisy. According to the philosophy of Python, tabbing and white space is much easier to look at and a little bit easier for you to understand what's going on. And so it's simply tab in for every function. And in this function, I am just going to create another variable called sum. And I'm going to let that equal to the variable a plus b. And I can also have a return. And then what I want to return is the sum. So what this function does is when I start it, it'll grab two numbers here in they call these the arguments or parameters. And then those numbers will then, something will happen to them. They will get summed together using this plus symbol. And then it will then return the result of this function. So how do I use a function after I've created it? Well, now I can just type in add number. I need to make sure I have the parentheses. Now, if I look up here, it's actually giving me a little bit of information, A and B. So I'm getting that inspection to say exactly what it's accepting. So I'm going to have to put in 2 arguments. So let's have a number 3 and a number 4, and then enter. Now this function will run. I need to have something for that to go into. So another variable, so it'd be a container for that. So what this will do is now this returns sum, everything that's gone through here. So that the 3 and 4 will go in. We're going to do a little bit of work here, A plus B, and then the sum comes back out and then ends up being the result. If I want to see that result, I can actually print it to the console or the terminal and go print the result. So I'm just going to save this. I'm going to right click up here in the text editor. I'm going to run the Python file in the terminal. So if you look down here, there's now an output onto the terminal, 7. So it's grabbed my number 3 and 4, and it has printed them out. I'm not just limited to hard coding in numbers. If I look up here, say I want to have a number here and a floating point. Okay, let's try that. Why not go to here? I'm going to type in a variable number. And what was the other one here? That was the floating point. So you'll notice very quickly, these are 2 different types. So let's see what happens. In other languages, this would spit up an error because number is of a type int, and then the floating point is a float. And other languages do not like having 2 different kinds of things getting added together, but Python's pretty smart. It has the ability to figure out some of this stuff on its own. So you can see I've got 49. So that looks like it is correct. What's happening under the hood is Python knows how to convert numbers back and forth, and it's figured out, okay, I'm going to add this int into a float. I know how to do that. I'm just going to convert this one into a float, put them all together, and you can see the end result is a floating number as a result. So that's not too bad. What if I have something like this, where I've put in double quotes, I've now made this a string, and I'm adding it to a number. Let's see if this works. Okay. The short answer is no, it does not. So if I have a look here, it's spit out an error. So it tells me in my test.py file, and it shows me where everything started going wrong here, and that is in that function where I have it. So it says, what is the error? It says here, it's a type error, unsupported operand type. So int and string, it doesn't know how to combine them, so it's not going to let you do it. So I've got one more thing of note here. You need to understand, because Python is dynamic, there are what we're going to call compile errors in most languages that pick up this type problem that I was showing, where it spit out an error. You notice it didn't show up as an error in the editor, which is a bit of a problem. It is kind of nice to find all your errors before you run. And that's one of the disadvantages of having an interpreter. Some of these errors you are not going to get until you run the program. So even if you have it all in place, you figure, oh, it's been running for years, you may run into bugs. So one of the things that you need to do at the end is you need to use more tests. So there is runtime testers, there is libraries that are available that can help you catch these bugs, because they are not caught. That's why a lot of folks are still kind of uneasy about using Python. But if you're trying to just throw something together as a prototype or a proof of concept, it's a great language. If you want to get something that's a little more enterprise ready, it's going to run in the back server for years, never be shut down. You're going to want to be looking at a stronger system that which you can probably get with the C and the Java. So we're going to have a look at what I'm going to call the globals. So inside Python, actually, there is a lot of stuff that's available. I'm going to start with one of the issues that you may run into is the versions of Python. In my case, I'm running a Python 3.7. And if I type Python at the command line here, you can see it's defaulting here to a Python version 2.7. Well, that's not quite what I wanted. That in order to run Python, I will have to put a Python 3, and then it will run the correct interpreters. So I've got two different interpreters. Get back here. I'm going to look at getting help. If you are in the command line, we can go into the Python 3. It does actually tell you can type help to get some more information. So welcome to Python's help. So I'm going to have a look at here. This is what I'm really after. There's modules, keywords, symbols, or topics. So what is actually built in to Python? Well, let's have a look at the keywords. And it will start showing you a list of Python keywords. These are words that are built into the system. We are not allowed to use them as variables. And what's nice is with the code editor, it will actually show me these little bits there in blue. Those, when I type in, are going to be a different color. So I type in true, it's a blue in color. But I might have a variable called true variable, and that's fine. So this is a handy little list to kind of give you an idea of what is available. One of the nice things about Python is the use of words more so than symbols. It might be a little bit easier for you to read and understand. The other one that I want to look at here under the help is not just the keywords, but there are what you call modules. Modules are the same thing as libraries. Now these modules are built right in the Python system. And this is great because it's starting to actually gather all the modules that are in here. One of the beautiful things about that, it's telling me what modules I actually have, not just a list and then, hey, go find out if they're there. These are actual modules that are installed. So if I have a look here, we've got all sorts of things. Here's one that's important. It's being used here. We've got a sys. And you can see there's quite a lot included here. If you're not exactly sure what is that, well, let's go here. Type in sys. Okay, description. This module will provide access to some objects maintained by the interpreter. Sounds like kind of a slush description. So it's automatically generated from Python's source file. It might be incomplete. Anyhow, we can run down and we can start noticing that in that sys module, I have other variables, command line arguments. I also have the path and all these things that I have available. Now there's also functions. You'll notice here, these functions will have little underscores in front of them. This is a clue that these are built-in functions and they're not directly accessible. There will be a sys exit. What else do we have here? So that should be enough to get started. I just pressed Q to get out, and I'll press enter one more time. So what that allows me to do, if I want to get one of those modules, I can now import sys. And I am looking like I need to check something here. I can type sys. Okay, so it tells me this is of a type module and it's built in. It's not something that I created. Now, the other one I want to show you really quickly is when I type in a period after sys and press tab twice, you'll notice I get a list of all the different things. Now, this is the same list that you saw in the help. This is a really handy feature. If I don't need any details, I just want to know what's involved and what's in here. So this is one that can be used quite a bit here, the system path. So that is something that is available. So I can type the system path. And Python interpreter is pretty good. It'll start giving you the information. So system path holds this. You can see the brackets. Okay, this is a list. Well, what is it a list of? It's a list of all the various different paths that are available. So we can have a look through and see what all is included. Now we've got the web encodings, pi2.pi3. There's a pile of stuff in here. That gives you kind of an idea of where Linux is looking to execute various things. You can see here's a path down here. It might be a little more familiar. The user lib Python 3.7. So what that's telling the Linux system is if you can't find something, go look in all these places. So we're just having a look at the built-in modules. The other one we want to have a look at is the built-in functions. These will act very similar. So as I go through here, what are some of the built-in functions? Well, what do I get for free? For example, it's probably easier if I actually show you down here in the console. What I'm going to do is I'm just going to set up a message. Now what you're looking here is a list, and in this list I have two items. I have two string items. So I've assigned my message. Now this is probably one of the easiest things to look at. This message is of a type list. Now I also have, if I type in message, I can do the same thing what I did before where I press a period and tab twice. And you can see here, I've got all kinds of information. So I can do functions. These functions are built right in. So I have various things. I've got hello world and say I want to add something. So I have this ability to append. And in here, I am here, and I can press enter. So if I have a look at message, you can see what it's done is it's grabbed my original message, hello world, and now it's appended one more string onto the end of it. So we got all these built right in. The one that might be a little more surprising is if I have, say, a number is equal to 45. This will be very straightforward in other languages. If I type in number, it'll display 45 is what's stored in that variable. Okay, that looks good. But what might come as a surprise is I actually can hit tab twice, and there is a few functions that are attached to this object. Now, it's not just a number. So I can convert these things. It'll have a look here. It'll tell me what the bit length is, for example. So let's try that one out. We got bit length. So if I wanted to get a little more information about my number. So Python has gone in and it's now telling me that the bit length of this number is 6. Okay, well, that's pretty neat. What if I go to float or floating? I can go to 4.0, and then I will hit tab twice. So now I can actually convert this into a hex number, floating, turn it into an integer. The next one here I want to show you is some of the included ways to get information in and out. So what we have included here is a print function. There's an input, open, and a range function I'm going to show you. Okay, here I'm going to show you how to use the input and the print functions. So I've got these two numbers I want to add in, but I'm going to let the user give them to me. So what I can do is I'm going to let A equals input. And what this will do is it'll grab the input from a user. I can enter first number. And I'll let B equal enter second number. Might be a good idea actually to put a print statement up there, let the user know exactly what you're doing. Enter two numbers. And they will be added together. So now I've grabbed these two inputs from the user. I have to run my function. I can add number. I can go A and B. I don't want to forget my result here, so result is equal to add number. Then I can go to print result. So I can go, the result is let's see what this gets. I'm going to save the file. I'll just close the terminal. So if I run file and terminal, so you can see if I go line by line, I started up here, enter the two numbers, that comes onto the screen. Now it's asking me some information here. It's actually giving me the input. So this string is now displayed, enter the first number. I can put in a 45, I'll hit enter. Okay, this is good. So now I'm moved on to line 20. I can enter a second number. Let's go 40, just make this easy. And then I'll hit enter. Because there's a type inference, you can have a look at it right here. This is where I'm going to run into trouble. Python is guessing what kind of things I want to throw in here. You can see when I do an inspection, it's a string and a string. So it grabbed what I entered here as a string and grabbed that as a 45 and grabbed this as a 40 and put them together. So it did actually what I wanted it to do. Maybe it wasn't quite what I'm after. My default here is string, and what I've typed into the console isn't actually truly a number. I'm actually typing in strings. So one of the tricks that we have here is before we run this through our function, I can actually take my A is equal to itself and B and what this function does is it will convert a number string into an integer. And that will allow me to then put these into an A and B as numbers. So I'm going to go run file. Okay. Now I've got the result is 45 plus 40. It is now 85. You might want to notice something about the flexibility. I actually started off with a string type coming in. See if it wants to show up. The A here is a string type, and then I was able to convert it into an int type. This kind of flexibility you won't find in other languages. This can be extremely handy in some cases. It can be very frustrating in others if you are trying to debug. Going to show you here. So what is open? It's a built-in function. What this allows me to do is actually open files on my computer. So I'm going to open text.txt file, And it takes as its arguments is whether it's a read or a write. I'm going to say that it's both. So it says here must have exactly one read, write, or append. Okay. I'll play along. So I'm going to write because I know that this file doesn't exist. So I'm going to write this file. It gives you some information here. It'll actually give you the name, the mode, and also the encoding is a UTF-8. You don't need to know too much about that, but there are different encodings. If I look down here, I can actually select different encodings. It won't tell me, but there is things like ASCII and various other ones, but UTF-8 is now the universal encoding for text files, but you might have to have the option of switching that. So now that I've opened that, I can actually, oh, I need a handle, hang on. I'm going to go file is equal to open text.text. So what that does is this letter F, this is a variable that gives me access. So I go F dot and I double tab. It'll actually show me all the various different things that I can do. I can close the file. Not quite ready there. I can read the file. I won't find anything. What I'm after here is the write. So if I can go to write, and I can put in a hello and enter. And then I can go F close. What this is telling me is the output of F write actually tells me that 1, 2, 3, 4, 5 characters have been written. And make sure you close the file, because right now, if you leave it open, there is a possibility that it can get the data can be corrupted. So then I can go to F close, and now it's closed. If I look here on the left-hand side, text, in the program, I've actually put hello onto the text file.